Alright, we're going to look at Lesson 8-7, Slope-Intercept Form. Up till now, we've had equations with one variable. Now we're working with linear equations. They're called linear equations because they form a straight line. And we're going to have two variables in our equations, y and x. Where you see the variable m, that number will represent our slope. And where you see the variable b, this will be our y-intercept. When we graph it, it will be where the line crosses the y-axis. Looking at this first example, first thing we want to ask ourselves is y by itself on the left-hand side? Yes, it is. So this is slope-intercept form. Negative 2/3 will be our slope, and negative 5/10 will be our y-intercept. And they've indicated that right here. The variable m represents slope, the variable b represents our y-intercept. Let's try some at the bottom. The first question you're going to ask yourself is the equation written in slope-intercept form? First problem, y equals 4x plus 12. Y is by itself. So the coefficient of x is our slope. The constant, which is by itself, is our y-intercept. Same thing with question 2. Is it in slope-intercept form? Y is by itself on the left-hand side. Negative 2 is going to be our slope. And our y-intercept is going to be negative 1. Problem number 3. Is it in slope-intercept form? Is y by itself? Yes, it is. We don't see a number in front of x, but remember, in front of the variable is 1 and also a negative sign. So this means our slope is negative 1 and our y-intercept is 4. Alright, let's skip to number 5. Once again, y is by itself, so our slope is 5/6. That means we would count up 5 over 6 when we plotted it on the coordinate plane, and our y-intercept is negative 8. Okay. Now for the next problem, when we ask ourselves that question, is this equation already in slope-intercept form? 5x minus y equals 22. Well, y is not by itself, so I have to rearrange this equation to get y by itself. First, I'm going to move the 5x by subtracting 5x to both sides. This leaves me with negative y equals, I can't put these together because they're not like terms, so I'm going to put the x value first, negative 5x, and that's positive 22 plus 22. Remember, the number in front of the variable is 1 unless otherwise written, and this happens to be negative 1. So if I divide to undo the multiplication, I've got to divide everything on both sides by negative 1. And remember, when you multiply or divide by negative 1, the number just changes its sign. So negative 5x divided by negative 1 is positive 5x. Positive 22 divided by negative 1 is negative 22. Now that it's in slope-intercept form, y is by itself, we can say that the slope is 5 and the y-intercept is negative 22. That was problem number 6. Alright, number 7. It's not in slope-intercept form, so again we're going to have to rearrange it until it is. So, number 7 was 3x plus y equals 8. Y is not by itself, but we won't have to do much to get it by itself. I'm going to move the 3x to the other side by attaching its opposite, negative 3x. Y equals negative 3x plus 8. Y is isolated by itself. Its coefficient is positive 1. We can identify the slope is negative 3, and the y-intercept is 8. Okay. Let's see. Here's another example just to make sure you're ready for anything. If we have 2y minus 8x equals 16, well, the first thing you notice, y is not by itself. So we're going to move the negative 8x first by attaching its opposite. And all we have to do now is undo the multiplication by using division. Everything gets divided by 2. 8x divided by 2 is 4x. And 16 divided by 2 is 8. Now it's in slope-intercept form, so we can identify the slope as 4 and the y-intercept, as positive 8. Okay? Next, we're going to try graphing some equations. First thing they have to be is in slope-intercept form. Looking at problem number 1, our slope is 4 and our y-intercept is negative 1. When graphing, you're going to start with your y-intercept. The y-intercept is on the y-axis, negative 1. From that point, we can now count our slope. And our slope is 4, but we needed a fraction so we can count the rise over run. So we're going to simply change that to 4 over 1. The rise is positive 4, so we go up 4 over 1. Plot your point, and then draw your line. Okay? Next equation, problem number 2. The slope is 6. The y-intercept is 4. If we go to the y-axis, go to positive 4, we know that 6 is 6 over 1. If we go to count positive 6, up 6 over 1, we're out of graph paper. Now, we can go down and back. So, if we go down 6 and back 1, before we connect the points, let's check. From this point to this point is the slope 6. Up 6 over 1. That works. And here's one with a fraction. It's already in slope-intercept form. We're going to plot 5 on the y-axis. Because we always start with the y-intercept. Now we're going to count this slope. And remember, that's rise over run. Since it's positive, we're going to go up 1 over 4. Up 1 over 4. This one should be right here. And then connect your points. Okay? So, when graphing, you have to make sure that it's in slope-intercept form. Identify your slope and your y-intercept. When you graph it, you're going to start with your y-intercept. It's on your y-axis. And then you're going to count your slope to get to the next point. And then connect your points and you've got your line. And remember, these are linear equations because they form lines.